You do not have this PowerPoint. This is one that's way too advanced for me, so I found this online. So just follow along. You don't have to take notes on it. You already have the notes. This is just trying to take us through what's going on. So DNA and transcription. So it reminds us that DNA is divided in sections called genes. And it talks about 25,000 genes on our 46 chromosomes. Proteins are made of, and by now we know proteins are made of amino acids, so it said correct. So it says genes are our blueprint. They're going to tell us what proteins we want to make. Which organelle creates proteins? Well, hopefully you know that makes energy. These are the suicide sacs here. Chloroplasts, they make sugar. That leaves ribosomes. So now they're doing an analogy. And here they're going to talk about architects using blueprints to make a building. So I guess they probably don't use blueprints as much nowadays with the beautiful digital printers. And the blueprint, though, traditionally would take the information from the architect to the builder so they could build things properly. So it says the gene is like construction blueprint. It's telling how to make the right protein. A gene is a small section of, and we know that's got to be DNA. So we have to have transcription. And transcription happens in the nucleus. That means we're copying a small section of DNA. Could be a big section. We're copying DNA. So it says the red letters, this is part of the DNA. That's our template strand. And the green are the nucleotides that come in, and it says ribonucleotides because of ribonucleic acid, and they're going to come in. Notice no T's in the messenger RNA. A normally goes with T in DNA, but in RNA it's a U. The T gets replaced. T goes with A, G with C, C with G, T with A, etc. So, where's DNA stored? We know that's the nucleus. Okay, so here's our DNA, and the first thing that has to happen is it's got to unzip. There's an enzyme. We don't have to worry about that enzyme this year. And so we've just got to go through and separate out the two strands of DNA. Now, come on, where'd our arrow go? There we are. Okay, so that should be separated out. And now this is opened up, so now messenger RNA can come in. So friendly reminders. A will go with U, T with A, C with G, G with C, no problem there. Now, if we have a T, we know that's got to be an A. If it's an A, we know it's got to be a U. C must be with G. A, well, A was with U, so it's still going to be with U. G, well, better be C. And if that's G, we better find a C. And of course, if that's T, we better find A. So messenger RNA is now going to go to the nucleus, so you're going to see it detach and leave. And the DNA will then combine again. So there goes the messenger RNA to the ribosome. And now the DNA can reform, and we can move on to the ribosomes. So, it talks about that there. The blueprint has been sent to the construction site is what they're saying. So our next PowerPoint, we're going to look at translation. We've sent the information to the ribosomes, and we want to see what is happening. So we have that arrow. Oh, maybe I clicked that already. That's good fun. Okay, there we are. So there's our ribosome. Messenger RNA is coming in. It has the codons. and it's going to link up with the ribosome, and transfer RNA is going to arrive. So here's our messenger RNA, and it's going to be processed through the ribosome, sort of like sliding things along a zipper. Yeah, boom. What will eventually be created by the DNA code? What are we trying to make? The whole point is to make protein. Polymerase, start, and which type? Well, whenever you see ACE, that means enzymes, and enzymes are always proteins. Okay, transcription done properly. Well, A with U, C with G, that's good. Boom, boom, that looks pretty happy. We see we can't have any T's, so that wipes out these. And A with U, C with C, C with C, that makes no sense. It's got to be complementary. And where will the finished messenger RNA travel? We know it's going to a ribosome. Boy, oh boy. What process begins? Got to be translation. That's enough of that. So that was all about transcription.